All right, so we are on 5.3. It's linear programming in 2 dimensions. It's a geometric approach. So linear programming is a mathematical process that has been developed to help management in decision making. Linear programming problem is one that is concerned with finding the optimal value, the max or the min value. The feasible region is the set of points that satisfy the constraints of the problem. And if the feasible region is not bounded, then there is no max value. If it is bounded, then both the max and min value of the objective function always exist. The objective function is in terms of the decision variables that we plug the corner points into, or plug corner points in to determine the optimal solution. It can be a profit function, a cost function, income, and so forth. Optimal solution is any point in the feasible region that produces the optimal value of the objective function, and it occurs at the corner point. Problem constraints are the limits imposed in the problem. Example is non-negative values. So that's like where when we have x greater than or equal to 0 and y greater than or equal to 0. So non-negative. Steps for solving a linear programming problem with 2 variables. We're going to graph the region, construct the corner point table, determine the optimal solution, and for an applied problem, we're going to interpret the optimal solution. All right, so for example 1, we're going to solve the system graphically and indicate whether the solution region is bounded or unbounded. And then we'll find the corner points of, or find the coordinates of each corner point. So we have 4 equations this time. So far we've done like 2 equations, but we are going to do 4. So we're going to start with that, and for each one we're going to find the x-intercept, we're going to find the y-intercept, and we're going to do the test points of 0, 0. All right, so this is 5.3, and this will be example 1, and we're solving the system again. So I'm going to write the equations in separate spots here. So we have negative x plus 6y greater than or equal to 3. So I'm going to write each equation as we go through it, so I don't have to keep rewriting everything. All right, so the first thing we do is find the x-intercept where y is equal to 0. So negative x plus 6 times 0 equal to 3. So negative x will be equal to 3. Divide by negative 1, and x equals negative 3. So our x-intercept will be negative 3, comma 0. All right, our y-intercept is where x will be equal to 0. So negative 0 plus 6y equals to 3. 6y equals 3. Divide both sides by 6, and we get y is equal to 3/6, which reduces down to 1/2. So we have 0, 1/2 as our y-intercept, and now we need to do our test of 0, 0. So negative 0 plus 6 times 0 greater than or equal to 3. Well, that still gets us 0 greater than or equal to 3. This is false. So that means it's not going to be in our solution. All right, our next equation is going to be 7x minus y greater than or equal to 20. And it doesn't matter which order I solve the equation parts in. All right, so our x-intercept, again, y equals 0. 7x minus 0 equal to 20. 7x equals to 20. Divide by 7, and x equals 20 over 7, which gets us 20 over 7, comma 0. All right, our y-intercept, where x is equal to 0. So 7 times 0 minus y equals 20. Negative y will be equal to 20. We'll divide both sides by negative 1. and y equals negative 20. So 0, negative 20 is our y-intercept. Excuse me. And now we'll test 0, 0. So we have 7 times 0 minus 0 if it is greater than or equal to 20. So we get 0 minus 0, which is 0 greater than or equal to 20. This again is false, so it will not be in our solution. All right, our next equation is x plus y less than or equal to 12. We're going to do the same things for this one. We'll have our x-intercept, or y equals 0. So x plus 0 is equal to 12. So x equals 12. We get 12, 0. Then is our y-intercept, where x is equal to 0. So we get 0 plus 0 equal to, 0 plus y equal to 12. So y equals 12. I got ahead of myself thinking we were doing the test point. All right, so let's look at a 0, 12 as our y-intercept. Now we'll do our test of 0, 0. So 0 plus 0 less than or equal to 12. It is, so this will be true. So that means that 0, 0 is in the solution for that. And then we have one more. We have x is less than or equal to 9. So that means this is a line of x equals 9. It's a vertical line. And all we need to do is test. We don't need to find the x-intercept because it will be 9. There will not be a y-intercept. So we're going to test 0, 0. So 0 is less than or equal to 9, and that is true. All right, so the next thing we're going to do is we are going to graph. I'm actually going to pull out my ruler for this one to make sure I draw some pretty straight lines. I probably should have had some graph paper, but we'll be okay. All right, so 20 divided by 7, that's almost 3 because 21 divided by 7 would be 3. So this is close to 3. This is negative 20 for the y, so we're going to have to go down to negative 20. That'll be our low, about 3, but we have 12 on this side, so up to 12, down to negative 20. On our x values, we've got a negative 3, about a 3, but we have 12. And we also have 9. So we're going to need to go up on the y at 12, down to negative 20, and over to negative 3 for the x, and positive 12. All right, so let's draw our graph. I'm going to kind of scooch it over so we have room to do stuff. All right, so we'll go up as high as we can. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm trying to make them even. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, we're going to draw our, I probably put these a little too close together, but that's okay. We're just doing a sketch here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we've got negative 20 down here. We've got positive 12. We have 12 here. We have negative 3. And we're also going to need to know where 3 is for our x, because we'll be right in front of 3. We need to know where 9 is, 4, 5, 6, 7, 8, 9. And we're going to 1/2 we can find. All right, so I think that's everything we need. All right, so the first point, or the first graph, we have at -3, and y is at 1/2. So I am going to use my ruler because I'm doing 4 lines here, and I want to try and make them as good as I can. And I want to go out as far as I need to. So this is our line of -x plus 6y is greater than or equal to 3. All right, our next line, or graph, is this one. So we're going to be at 20/7, which is almost 3, and at -20. And again, this is not a perfect graph because my spacing is not exact. But we're just going to go and do the best we can, because to find our corner points, we are going to use minus y greater than or equal to 20. We're going to solve with the system of equations. So this just gives us a graphic representation. All right, the next line we have is x plus y less than or equal to 12. So we're going to do that in purple. So we have 12 for our x-intercept and for our y-intercept. Okay, so let's graph both of those. So we've got x plus y less than or equal to 12. And then we're going to use pink. Hopefully it'll show up a little bit different. We've got x equal to 9. So we're just going to try and draw a straight line as best we can according to our graph. So it's kind of parallel to that. So this is not going to look great. I'll show you my one in pencil that I did for the lesson plan here in a minute, because it's kind of on the wrong side of big points because I'm not as even as I should be. So this would be x less than or equal to 9. And what I mean by that is on my graph, there should be a flat line there, and that's where you need to have more even spacing. And this is not perfect either, and the spacing, it would be better if I did it on graph paper, but we just get an idea of it. So the problem is this line should be more right here, but we're all good, and it's because I made these smaller than these. But we're just doing a graphic representation, okay? So that we can figure out what our corner points are. All right. Now, all of them were an equal to, and that's why they all got solid lines. And they're going to be hard to see on that graph, so we're going to have to do some systems of equations because we need to find all 4 corner points. None of them are intercepts this time. We have a corner point. Let's see if I can pull another pen color. Let's see if our orange will do. We've got a corner point here, a corner point here, and we will actually have 2 corner points right there because of how it will graph. Now, let's talk about how do we know this. You haven't shaded it yet, so let's talk about the shading. So this one was false and this one was false. So this line, which was the -x plus 6, this has to graph up. The 7x minus y is here. It was false, so it has to graph on this side over here. This one was true, so this line has to graph down here, and this one was true, so it has to graph on this side of the line. And that's how I know that this is our shaded region, is by whether or not this point over here, is it above it, below it, to the left, or to the right. And that's how we know it's going to be this shaded area. All right, so let's go find our corner points. And I apologize that I didn't space as evenly so that it doesn't look as beautiful on here. But again, you can always graph on Desmos, or you can graph using a graphing calculator to get a more accurate looking graph. So now to find the corner points, we need to actually solve the system. Now, like I said, you could use the calculator to do the homework, but you got to know how to do this in order to do the test. Now the test, I won't have you find this many corner points, but you might need to find one like we did in 5.2. All right, so let's do our first corner point. Let us do the negative 6y and the 7x minus y. So we're going to take these two equations and we're going to set up a system. All right, so we need to have a system. So this will get us negative x plus 6y equal to 3, and 7x minus y equals 20. All right, so I need to either cancel out x or cancel out y. I think I'm going to multiply by 7 up here because my number is a little bit smaller, and leave this one the same. So we'll multiply by 7. And this one will be no change. All right, so this will get us negative 7x plus 42y equals 21. So 7 times negative x, 7 times the 6y, and 7 times the 21. No change means this will come right on over. The x's will cancel. 42y minus 1y will leave us with 41y, and 21 plus 20 will get us 41. So y will be equal to 1. Now, I need to plug in y equal to 1. I think I'm going to, it doesn't matter which one I choose. I need to solve for my x. You can choose either one. I think I'm just going to pick the top one, but it doesn't matter. So I have negative x plus 6 times 1 equal to 3. So negative x plus 6 equals 3. Subtract the 6 over, and I get negative x equals to negative 3. Divide by negative 1, and x equals 3. So between these 2 points, I have our 2 values that gives me the point of x3, y1. So that is where these 2 lines overlap would be 3, 1. So that's this one down here. So this is our first one that we did. This is like number 1, okay? Now, let's go find our second point. So for number 2, we gotta make a new system. So let's do the negative 6x plus 6, or negative x plus 6y equal to 3, and we'll do the x equal to 9. So we're gonna do where these should overlap. All right. Well, I can just add these together because I have a negative x and an x. So this is our system. So I'm just going to add them together. My x's will cancel. I'm left with 6y equal to 12. Divide by 6, and y equals 2. Now let's plug y equal 2 into the first equation. So we get negative x plus 6 times 2 equals 3. So negative x plus 12 equals 3. Subtract the 12 over. We get negative x equal to negative 9. Divide by negative 1, and x equals 9. So that means for this one, our point will be 9, 2. So we're at 9 and 2. Okay, and it doesn't quite look like 2 there because, again, I didn't do even spacing. I'm so sorry you couldn't see what I was doing. All right, so we're at 9. That does not look like 2 because 2 is way down here. So just be aware. All righty. So next thing we're going to do is we'll set up a third set of equations. So our third set of equations are going to be, let me move this up just a little bit. I'm going to bring the third one over here. So we'll do the x plus y equal to 12 and the x equal to 9. So that is our x plus y equal to 12 and our x equal to 9. And you'll notice I'm setting these as equal to because we're trying to solve it where they intercept. So that's why we're not doing the inequalities in these. We're doing the systems of equations. All right, I can't just add it this time because I have 2 positive x's. So what I'm going to do is no change on the top. Bring it on over. And this one I will multiply by -1. So that will get me x plus y equal to 12, negative x equals -9. When I add those, I'm left with y equal to 3. All right, let us plug in, plus y equal to 3 in. So we'll have x plus 3 equal to 12. Subtract our 3 over, x will be equal to 9. And that'll give us the point of 9, 3. And we're finding, hey, that's just what that equation was, each time x equals to 9. But that way, in case you don't have an x equal to 9, you can see just how we would do this. All right, so we've got our third one. So let's go to our fourth system. Our fourth system is going to be our 7x minus y greater than or equal to 20, and our x plus y equals to 12. So that's our fourth one. So we did number 2, we've done number 3. This will be our fourth point. So we have 7x minus y equal to 20, x plus y equal to 12. Now, as I look at this, I'm like, all right, I can just add this one, and my y's will cancel. So that'll get me 8x equal to 32. Divide by 8, x equals to 4. Now we'll plug x equals to 4. It doesn't matter which one. This is probably the easier equation. Again, I'm sorry, I'm not watching my screen there. So we just added that, got 8x. The y's canceled. We got 32. Divide by 8, x equal to 4. So I'm going to use the second equation here because I think it'll be simpler than doing the top one. So we're going to have 4 plus y equal to 12. Subtract the 4, and we get y equal to 8. So 4, 8 is our fourth corner point. So I'm going to now make a box for you that we have the corner points are going to be, we found 3, 1, we found 9, 2, we found 9, 3, and we found 4, 8. So these are the corner points. And our solution is bounded, again, because the graph is covered on all sides. Okay, so be careful if you're graphing this by hand. Make sure you overlap each set of equations to find what the lines were. Because on this one, I didn't graph it very well like I did when I did it on paper. And therefore, I couldn't see that the line went there. I did a better thing on my line. And again, you can use Desmos and you can use a graphing calculator. On an exam, I won't make you do this much. You don't have enough time. It would be more like the question on 5.2 where you are given to find like one corner point and the others are intercepts. Okay? All right, let's go to example 2 because example 2 is a little bit different than just getting the equations. We're looking at a manufacturing company makes 2 types of water skis, a trick ski and a slalom ski. The trick ski requires 12 labor hours for fabricating and 1 labor hour for finishing. The slalom ski requires 8 hours for fabricating and 1 hour for finishing. The maximum labor hours available per day for fabricating and finishing are 192 and 20, respectively. Respectively means that you're doing in the same order. So slalom, let me think. Sorry. It's 192 to fabricate, and then 20 for finishing. All right. Find the set of feasible solutions graphically for the number of each type of ski that can be produced. All righty. So what we're going to do here, this is types of skis. We're going to create a table. So what we know is we're going to have something about labor hours. And we have trick skis. And we have slalom skis. And we also have the max available. And then we also have fabricate and finish. Those are the categories that we were given. All right, so let's go back. For trick skis, and they make 2 types. We have trick ski and slalom ski. The trick ski requires 12 labor hours for fabricating, so 12, and 1 for finishing. The slalom ski requires 8 hours for fabricating and 1 hour for finishing. The maximum labor hours available per day for fabricating and finishing are 192 for fabricating and 20 for finishing. Find the set of feasible solutions. All right, so in this case, we weren't given equations. We actually have to create them. And that's the difference on this one. So this will be our 12. We're going to call our tricks there the x plus 8y. The max available is 192. So it can be less than or equal to 192. We can't go over 192, and that's how we know it's going to be less than. It can include 192, but it can't go more than that. This one will be x plus y less than or equal to 20. We also know that if we're making things, we can't make a negative thing. So it can't be negative, so we know that x is greater than or equal to 0 and y is greater than or equal to 0. All right, so this, we would do the same process. We've got basically 2 equations because this is just going to be our x and our y axis. And you would find the x-intercept, the y-intercept, and the test point. I'm actually not going to show all of the work, so the video is not super long. We did, on the last problem, we did 3 sets of those, so I'm just going to tell you what each one is. So on the 12x plus 8y less than or equal to 192, the x-intercept is going to be 16, 0, and the y-intercept will be 0, 24. And on the test point of plugging in 0, 0, it will be true. All right, for our second equation, for x plus y less than or equal to 20, our x-intercept will be 20, 0. Our y-intercept will be 0, 20, and the test point is true again. Okay, so finding the x and y intercepts and the test. That way you don't have to listen to me do all of that. And you should know how to do that. If not, go back up the video and watch what we did on the last two, where we take our x-intercept, y equals 0, y-intercept, x equals 0, and put in test 0, 0. All righty. So now that we have our points, let's draw our graph. So we've got 16, we've got 24, and we've got 20. So we're going to count by, let's go with 5s. We've got enough room. I'm going to do a better job this time of trying to have 5, 10, 15, 20, 25, 5, 10, 15, 20, 25. All right, so for our first line, we will do the red. Well, let's go with the colors that we did the markings in. So 16, so that's 5, 10, 15, so we're at 16. We'll go ahead and count these out. 5, 10, 15, 20, and 25. Okay, we've got 16 and we've got 24, so right there. All right, so this will be that line. And then our other one is going to be at 20 and at 20. All right. So now with our two equations, we also know that the test was true. So with that trueness on the test, we can shade our graph. Because they both tested true, it will be this area here. And we only shade the part where they overlap in their solution. We're not going to shade those parts because it's not true for both. Okay? So now that we've got this part, we can start with our corner points. Now, I'm also going to label this a little bit. This is going to be, this is the number of trick skis versus our slalom skis. And this will be slalom. Yeah. Okay. Now, and I hope you notice when you go to do the homework, a lot of these are very, very similar as to what you need to do. All right, let's see what all we had to find. It said, find the set of feasible solutions graphically for the number of each type of ski that can be produced. So that's all we had to do was graphically do this. They're not asking us to find a corner point this time. But if we did, we know we have a 0, 0, we have a 16, 0, we have a 0, 20, and we would, again, if we wanted to find that corner point, then we would be looking at taking the two equations and making a system and solving. But we're not asked to do that on this problem. So that's all you have to do. All right, let's go on to example 3. So for example 3, it says to solve the system linear programming, maximize p equals 10x plus 10y subject to this. So this one includes a little bit more because we're being asked to maximize, find the maximum point. So let's go solve this one. So this will be example 3. And again, we've got a couple of equations. There's nothing to do with the x and the y. We're only going to have to do the 2 for our x, y intercepts and the test point. So we have 2x plus y less than or equal to 40. So again, I'm not going to show you how to do the x and y intercepts and the test point again. I'm just going to tell you what they are. So our x-intercept would be 20, 0. Our y-intercept will be 0, 40. And our test point of 0, 0 is true. For our second equation, which is x plus 2y less than or equal to 32, our x-intercept will be 32, 0. Our y-intercept would be 0, 16, and our test of 0, 0 again will be true. That way we don't have to just do that. You can pause and find them yourselves, but I just didn't want to repeat myself a lot doing this. All right, so we've got some big numbers here, so I'm going to count by tens. We've got to go to 40 on the x and the 32. So I'm just going to go 40 on both. So I'll do like 10, 20, 30, 40. And then 10, 20, 30, and 40. All right, so for the green one, we had 20, 0, and we had 0, 40. All right, so let's draw our line. And then for the red values, we had 32, somewhere we're like right there, and 16, so about halfway and a little bit more. All right, and on our graphs, the test point of 0, 0 was true for both. So it's going to be this part right here. This will be our solution. Now, on this one, we were actually asked, this is on example 3, it says to maximize. So to maximize, we're going to need the corner points. So let's go find our corner points. We have some of them right away. We know that we have, this is our y-intercept, and that's at 0, 16. We have 0, 0. We have 20, 0. But we need to find that fourth one. And how do we find that? We're going to do the systems of equations where the lines overlap. So we're going to do our system of 2x plus y equal to 40 and x plus 2y equals 32. Now we don't have anything where x or y will cancel, but we can use what we know. I'm probably going to multiply the bottom one by -2 just because that has the bigger numbers, but it doesn't matter. So this one will be no change. And this one will be multiplied by -2. All right, so this will leave us with 2x plus y equals 40, and then -2x 2y times negative 2 would be negative 4y, and negative 2 times 32 would get us negative 64. The x's cancel. We're left with negative 3y equals negative 24. Divide by negative 3, and we get y equal to 8. So now we will plug in y equals 8. And I'll probably use the bottom equation. So we have x plus 2 times 8 equals 32. X plus 16 equals 32, so x equals 16. So that means our point will be 16, 8. All right, so we'll put that up here. So those are our corner points. We need to know what those corner points are in order to do the maximize. So to maximize, we are going to sub the corner points into the equation of p equals 10x plus 10y, which was what we were given. We were given p equals 10x plus 10y. So we're going to maximize that. All right. So we've got our first corner point. We've got 0, 16. So that means we've got p equals 10 times 0 plus 10 times 16. So that's going to get us 0 plus 160, so equals 160. Our next one is 0, 0. Well, that's not really going to help us, right? Because we get 10 times 0 plus 10 times 0 gets us 0 plus 0 equals 0. So it's not going to be the maximum on that, but it's good to understand. But you really don't have to test that one. Okay, our next one is going to be 20, 0. So we have p equal to 20, or we got 10 times 20 plus 10 times 0. So that's 200 plus 0 equals 200. And our last one will be 16, 8. So p equals 10 times 16 plus 10 times 8. 10 times 16 will get us 160. 10 times 8 is, oops, yes. 10 times 8 will be 80. I just saw a mistake in my notes, sorry. And 160 plus 80 should be 240. So 240. All right, so which one is our max? I'm going to create a table. We're going to do a corner point table. So in the corner point table, we will have xy, that's where your corner point goes, and the equation of p equals 10x plus 10y. All right, so we have the point of 0, 16. Order does not matter. We had 0, 0. We had 20, 0, and we had 16, 8. So for the 0, 16, we had a total of 160. For the 0, 0, we had 0. For the 20, 0, we had 200. And for this one, we had 240. So that means the maximum occurs when x equals 16 and y equals 8. So that's how and what that means as far as the maximized part. It's talking about figure out where you get the maximum P, which would be our profit, so that we know, like, what should we make? We should make 16 of the x and 8 of the y to get that maximum value. All right, we have one more problem. So we're going to try and do this one. This one's similar. To what we've done, but it's a little bit different. All right, so a manufacturing company makes two types of water skis, a trick ski and a slalom ski. The relevant manufacturing data are given in the table. So we're given a table. We've got a couple of questions to answer. If the profit on a a trick ski is 60, sorry about that, and the profit on a slalom ski is 55, how many of each type of ski should be manufactured each day to realize a maximum profit? What will that be? Discuss the effect on the production schedule and the maximum profit if the profit on the slalom ski decreases to 40, and what about the effect on the production schedule if the maximum profit on a slalom ski increases to 65? All right, so we're going to do similar things here. I think I'm going to kind of talk about this one because our video is getting long, and it's very similar to what we've done. And so I just want to kind of walk you through it. You've got the chart here. So this is going to be our 12x plus 10y equals, or less than or equal to 420, x plus y less than or equal to 36. Because it follows the chart, so I'm going to kind of walk you through rather than just work it. Because this one's basically the same as what we did, it's just a little bit different. So we set up the two equations. Let me bring this down just a little bit so you can kind of see the pencil a little better. We set up the two equations. We're going to find our x-intercept, our y-intercept, and our test point for each one. Then we're going to graph it. We can see our corner points again at intercepts, and we have to find the corner point that's right there on that part. So we had to do where our two lines intersect. So we found our 4 corner points. So it gave us, for part A, it said, what if 60 on the trick ski and 55 on the slalom ski? So the difference is we're going to have to set up the equations. P equals 60x plus 55y, coming from the prices they gave us. We're going to plug in all the corner points and figure out that our max profit is when we have 30 of the trick and 6 of the slalom. So we created our equation by the prices. Then what you'll do for part B is this, to talk about the effect. When we have 60 still on that one, it just says, the only thing it says is that one of them changes, and that's the slalom ski. So now we changed the 60 and the 40. Now we still have the same corner points. The corner points didn't change, but the equation did. So now we just got to see what happens. Well, when the slalom ski profit decreases, the max profit is now $2,100. On the previous one, it was $2,130, and when 35. So our corner point changes to which one would give us the max because the price change. And then on part C, the slalom ski changes again to 65. So we have a new equation, same corner points. You're just going to plug in on your equation. Now you've got 65 on the y. And what changes is now the max profit is $2,340 when no trick skis and 36 slalom skis are produced. So that's the only thing that's going to be different. You're going to do everything the same, But your P, when you have to create it with the prices they give you, and that's why you have to track what's X and what's Y, and then you're going to change it by the profit is going to change by how much you're charging for each ski. So it's the same process as the one we did, except now you've got to do it 3 times. Okay? So I thought I would just kind of show you what you're going to do. You don't have to write it all out. Just understand this is your X, this is your Y. So trick ski would be 60, slalom ski is 55. So if I'm doing, let's just show you how to set up the P. So for example 4, for part A, I've got, first of all, let's look at, we would have 12x plus 10y less than or equal to 420. And we'd have x plus y less than or equal to 36 off of our chart. And then for part A, we have P is equal to 60x plus 55y. For part B, we are changing the slalom ski, so P would be equal to 60x plus 40y. And then for part C, the slalom ski changes again. So P is equal to 60x plus 65y. And basically you're looking at, when we look at this, and I can write down the corner points for you. So if you're looking to graph this, your corner points are 0, 0, 0, 36, 35, 0, and 36. So the corner points won't change because the equations don't change. What changes is what is the profit for each one. So then you're just looking for those profit values. And you just got to plug in those corner points into each of those. And how do you find the corner points? Again, you're finding your x-intercept, your y-intercept, you're doing the test point, graphing it. Okay? And that's all that you're doing in 5.3 is creating these graphs, and then you're learning to maximize using your corner points.